Hi. So I'm sure you would have gone through the previous videos. See, what I am recording right now is part 6 of rational numbers. Okay. So if you jump into part 6 directly, there is a possibility that you may not understand it properly because it is a series which we are publishing. So for better understanding, please don't jump into videos. Please go through the videos in sequence. From part 1 onwards, you go through the videos. Okay. Then only there will be continuity and your understanding will be complete. So in the last video, we had checked the commutative property in whole numbers. We had seen commutative property in integers as well. Okay. So now let us ask this question. If rational numbers collections, okay, so when I say rational numbers collection, please recall it is the entire set of integers and fractions that I am talking about. Numbers of the form p by q, where p and q are integers and q not equal to 0. So these also includes integers, because if you take an integer 3, it can be written as 3 by 1, where 1 not equal to 0. Hence the integers are also rational numbers. It's part of rational numbers collections. Okay. So is rational numbers collection commutative under addition? The answer is yes. Rational numbers collection is commutative under addition. You can verify. So what do we mean by commutative property under addition? You take any two rational numbers, a, b, a plus b should be equal to b plus a. Right? A plus b should be equal to b plus a for any two rational numbers a and b that is drawn from the rational numbers collection. So I have an example. I have written down a small example to verify. Right? I'm not sure if this is legible. So let me read it out. Okay. I think from the video it is not very clear. So as I had advised you last time, you should have a paper and a pen with you. So I have taken in my example to verify whether rational numbers are commutative under addition. Two rational numbers I have taken. One is 5 by 2. The other rational number is 4 by 3. Two fractions I have taken. One is 5 by 2 and the second one is 4 by 3. Okay. So you just add these two rational numbers. Let us call x equal to 5 by 2. Okay. And y equal to 4 by 3. So I am defining two variables, x and y. I am saying let x equal to the first fraction 5 by 2 and y equal to the second fraction 4 by 3. Now if you add x plus y, which is 5 by 2 plus 4 by 3, okay, you add these two fractions. Now the denominators are 2 and 3 respectively. So the LCM is, least common multiple is 6. So you take LCM and the first fraction, what you have to do with 5 by 2, since the denominator is 2, you have to multiply it with 3 by 3. Okay. So the next step becomes 3 by 3 into 5 by 2 plus 4 by 3 into 2 by 2. So when you do this operation, your denominator will become same. Right? Now what you get is 15 by 6 plus 8 by 6. The answer is 23 by 6. So x plus y is equal to 23 by 6. Similarly, you calculate y plus x now. Y plus x is nothing but 4 by 3 plus 5 by 2. Again the LCM is the same. LCM is 6. because denominators are now 3 and 2 respectively. So the first fraction 4 by 3, you multiply it with 2 by 2. And the second fraction 5 by 2, you multiply it with 3 by 3. This is to make the denominators the same. So you get 8 by 6 plus 15 by 6. Where again we get 23 by 6 as the answer. So with this example, we can verify if you take any two rational numbers, x and y, x plus y is equal to y plus x. Or in other words, if we talk in a generic manner, any two rational numbers a and b, a plus b is equal to b plus a. Hence, rational numbers are commutative under addition. But rational numbers are not commutative under subtraction. Because, see, I have told you integers are also part of rational numbers, right? Whole numbers are also part of rational numbers. Rational numbers is much bigger set than whole numbers. Now, we have already seen whole numbers are not commutative under subtraction. You take any two integers, for example, 1, 2, okay, let a equal to 1, b equal to 2, a minus b is 1 minus 2, which is minus 1. b minus a, on the other hand, is 2 minus 1, which is 1. Both are not equal. So a minus b is not equal to b minus a for integers and for whole numbers, isn't it? Hence, since this is also part of rational numbers, we know for sure that rational numbers are not commutative under subtraction. Because if rational numbers would have been commutative under subtraction, you take any two rational numbers, it should satisfy the commutative property. But we know integers do not satisfy. Hence, rational numbers are not commutative under subtraction. But rational numbers are commutative under multiplication. You take any two rational numbers, you call the first rational number as a, second rational number as b, you find out a multiplied by b. It might look very, very obvious and trivial when you hear to what I am saying, but I strongly recommend that you take two rational numbers, just check it out on the paper, because this is going to get into your subconscious mind very deeply. You will not forget it. So for learning's sake, you try out with one example. Even if you know, try out with one example. Okay, write it down. Take two rational numbers, a and b. Find out a multiplied by b. Find out b multiplied by a. Check if both the answers are the same. They will be same. Hence, rational numbers are commutative under multiplication. And rational numbers are not commutative under division. Very similar to subtraction. We know if you take any two integers, they are not commutative under division. Hence, rational numbers are not commutative under division. The only exception to the commutative property in the case of integers is if you take both the numbers as 1. Right? Otherwise, for no other integer, if you take two distinct integers, it is not commutative under division. Whenever we talk of properties, we have to always mention under which operation we are talking about this property. Sometimes even I make mistakes. In the last video, after uploading, I figured out I am ending up saying that whole numbers are commutative, integers are commutative. It doesn't make sense if I just say commutative, right? So it is a common mistake that we all make, but we have to be conscious. So whenever we talk of property, we are talking of this property with regard or with respect to a particular arithmetic operation. So I will recap. Rational numbers are commutative under addition. Rational numbers are not commutative under subtraction. Rational numbers are commutative under multiplication. Rational numbers are not commutative under division. Okay, so I hope you have understood up till now very clearly. We'll proceed to the next property, associative property, in the next video. Okay, thank you.